Okay, so welcome back. This is a quick walkthrough of problems 3 and 4 on the gas laws intro worksheet that we're working on in class this week. And these two equations deal with Gay-Lussac's law, which governs the relationship between the pressure and temperature of a gas. And as we can see here, as the temperature increases, the pressure also increases. And we're also going to talk briefly about Dalton's law of partial pressures, which basically says that if you have a mixture of gases, the total pressure of those gases is the sum of all the pressures of each of the gases that contributes to the total. So kind of common sense, but John Dalton, who was the same guy who came up with the first atomic theory, was the first to figure that out. So without further ado, let's jump into this first problem here. And so basically what we're looking at here is something very similar to what we saw with Charles' law, where we have a proportion here. We have two fractions that we need to solve, and we need to solve specifically in this case for P1. So we want to know the pressure and the temperature change by a certain amount. And we want to know if we started at a certain temperature, what the pressure would be. So we're solving here for P1, the initial pressure of this gas. And the way we're going to do this in the beginning is the same way we did the other one, by starting with cross multiplication. So we're going to go ahead and cross multiply, and we're going to end up with P1 times T2. And I hope you understand here that if we put those two together, it's implied that we multiply them. So I'm going to go ahead and skip that step. Just to make it look a little neater. And then we have on the other side P2 times T1. So again, we're solving here for P1. And so we want to get P1 by itself. Since we're multiplying by P1 times T2 here, we want to divide both sides by T2 to get P1 by itself. And again, this is very similar to what we saw in the last example with Charles' law. So T2 is going to cancel out on the left side here, and we're going to end up with P1 is equal to P2 times T1 divided by T2. So again, if we know what the pressure changed to in the end, and if we know the initial and the final temperatures, we're going to be able to very easily figure out what pressure we started at. So that's problem number 3. On problem number 4, this is actually even easier because the equation for Dalton's law of partial pressures is just addition. We can add numbers all day long. And so what we're seeing here is that the total pressure, P total, is equal to P1 plus P2 plus P3. So if we had a mixture of 3 gases here, we would just add the pressures, what we call the partial pressures of each of these gases together, and we would end up with the total pressure of the mixture of gases. And so if we want to solve for P2 here, the rule, as always, is to do the opposite operation to get rid of all the other variables and to get P2 by itself. So if we're adding all of these variables up, we're going to need to subtract on both sides to get these things, to get P2 rather, by itself, because this is what we want to solve for. So P2, I don't know why I wrote a T there, but P2 is equal to P total. So if we know the pressure of the whole mixture of gases, like say a scuba tank or something like that, and then we're going, if we want to figure out just the pressure of this one gas, say nitrogen, we would subtract the pressures of all the other gases in the mixture. So P1 would be the pressure of the first gas, and P3 would be the pressure of the third gas. And so with that, we're able to, again, very easily figure out the partial pressure of that second gas. So that's about it. Hopefully these are starting to get a little easier for you. Hopefully you're starting to see kind of how the math works here. And as long as you can find these variables in a problem, you're going to have no problem. So hopefully that helps, and I'll see you soon. Bye.